Hi,
Hey,
what's happening? How are you?
I'm doing good, thanks. How are you?
I'm good. You have company back there, eh? Is that a
I
kitty
do. I've
cat?
got someone peeking over my shoulder over here.
Oh, that's
Look at
cool.
him.
Very, very interested. Eh? Kind of a big cat. Eh? It's one of those big cats, huh?
Oh, I'm not sure, but
Ah,
he's here nonetheless.
it looks friendly though. It definitely looks friendly. That's cool. So what's going
Absolutely.
on today? What's happening?
Well, I was just reading the other day this article which sounded a bit suspicious to me,
Okay.
and how black cats cause greater allergies than white cats.
Oh,
And I was
really?
like, yeah,
Okay. Okay.
I was like, that doesn't sound okay. Well, it sounds interesting. And then
Yeah.
reading this article, I'm noticing a bit of like inconsistency and misreporting.
Oh, okay. All right. So maybe some kind of something happened in the background that we weren't aware of, and they were thought to have carry more allergies or sorry, give people more allergies.
Mhm.
Wow, okay.
And the test that they used was a correlation test. And yet they came up with this cause and effect relationship, which doesn't
Okay.
quite make sense. And I realized that this was a biased paper and they were using causality bias, where they find a correlation or association between two things and then they just make up cause and effect to explain it.
Right. So basically they see some kind of correlation and they're kind of rationalizing what that there's some kind of an cause and effect going
Mm-hmm.
on specifically where things may not they may be correlated, but not necessarily a cause and effect situation there. Causality.
Exactly.
I got you. Okay. Yeah, that's got to be, kind of careful and make sure that when we're reading or when we're producing some type of papers that, that if there's any kind of bias in there, to be made aware of it, right? Make sure
Absolutely.
that we don't follow that practice. But yeah, yeah, it's wow, yeah, and then black cats get a bad rap for it, right?
Exactly. Like black cats have got enough going on. And now all of a sudden
They do, they
this article
do.
comes out and there's lots of types of bias that exist that can exist in research that you need to look out for. And another one is survivorship bias. Have you heard of that?
Survivorship. No, I'm not sure that I've heard of it.
So that is where you take the information that you have and you don't consider the information that you don't have. And it sounds a bit counterintuitive, but let's say that there's this medicine, and one study has shown that this medicine is effective against this particular disease,
Okay.
but 20 other studies show that it's not effective.
Oh,
But these
okay.
researchers probably feeling bad that they've had funding, they've done this experiment and the experiment failed, they didn't bother publishing it. So now
Oh, right.
one
Okay.
paper saying it's effective, 20 others are saying it's not, but those 20 other papers didn't get published in the end.
Wow. Okay. Geez. So depending on who's funding the research,
Mm-hmm.
they may not find the results that their the objective results
Mm-hmm.
are not something that they're happy with, I guess.
Exactly.
Wow, no kidding. Yeah, I guess I'm pretty naive. It's like, well, things like that can happen, and there's definitely a motive for that. You know,
Mm-hmm.
wow, wow, that's scary a little bit too, huh? A
It
lot of
is.
a
And
lot
that's
of
one of the trick.
information. I'm sorry. Go ahead.
No, I was just going to say that's one of the reasons why research is so tricky.
Okay, because there's other and bias is such it's a wide ranging term.
Mm-hmm.
So there's statistical connotation and there's more general. I guess I don't know if I'm not thinking of a particular example, but when we as a statistician we hear bias,
Mm-hmm.
we're thinking about how far away we have some kind of an estimator, right? And we want to see how close it is to the actual value.
Sure.
So some estimators are going to be unbiased, some are going to be biased, and it's nice to be able to calculate that particular bit of
Mm-hmm.
bias. Um, right.
Is
It's
that
like,
something that's sorry?
go ahead.
I was just going to say, is that something that's easy to do, making sure that your estimators are biased or unbiased?
It's basically, yeah, when you look at, we can go over an example if you
Sure.
like. Okay, so give me a second here. So as an example, let's say, let me pop up a whiteboard here. Hopefully this goes smoothly. We'll see. Okay. So
Okay.
let's say we have what's an estimator, like the sample mean. Okay.
Sure.
So let's say we have some kind of a random variable x, right? Okay.
Mhm.
And we're trying to find out the mean. And if that's an actual, um, so if my expected value for my random variable, okay, happens to be the mean. So we're saying that the mu here is what I'm expecting my random variable x to actually equal. That's what I'm expecting it to equal. That's the most popular result, I guess you can say. Okay. Well, it's basically, yeah, the mean. Okay. So if I may ask, all right, what's the expected value of x bar, right? Well, what is x bar, right? X bar is, and I'm not doing the best job being nice and neat here. So let me get rid of this here and rid of this here. And if we remember that X bar, right, is just I sum up all of my X's, correct? So I going from one to little n, if little n represents the number in our sample of these X sub i's and divided by n, correct?
Lovely.
Okay. So so basically I'm looking at the expected value of this expression that I'm denoting with X bar, right? This value of X bar, the definition. So that's the summation. Okay, I'm gonna leave out, if that's okay, my subscripts here.
Oh yeah,
Okay.
that's fine. We know what
Uh,
is going on.
yeah, what i's going on over there. So I 1 through n. So there's n of these x's. So let's do that. In fact, if I have an expected value, right? Something that if I have some random variable x, and I maybe should denote this, that if I have some random variable x, and I'm asking what's the expected value of something, some constant times that x, I could just say that it's that constant times the expected value of x. So I guess that shows some type of a linearity problem where you can factor out of the expected value function. Okay.
Excellent.
So that's what I'm going to do here with the 1 over n. Okay. So that's the expected 1 over n comes out, right? I'm dividing by it. N is a constant. And now I just have the expected value of the sum of these x's, right? So
Nice.
I'll just put in x1, right? So each one of these x's, x1 plus x2 plus all the way up to xn, right?
Nice.
So those are all values that I'm expecting each one of these to be, right? The I should say, when I said the expectation function has linear properties, meaning that if I had the expected value of, sorry, x plus y, right,
Hmm.
then that can be just the expected value of x plus the expected value of y, right? The
Yeah, makes
linearity
sense.
property that it has. Okay.
Like that.
Right. So going back up to here, hold on, I'm getting some pop-up stuff. So this in turn becomes 1 over n times the quantity of the expected value of x1 plus the expected value of x2 My handwriting is giving up on me. Plus blah, 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 plus the expected value of x3. Or sorry, xn.
XN, yeah.
I'm going all the way up to the xn's. Okay. So then another, we'll close this parenthesis over here. Okay. All right. Okay. So that's just n values of mu, isn't it?
It is.
Right. So that just becomes equal to 1 over n, and then n values of mu, because each one of those expected x's, expectation of x1, expectation of x2, those are all mu. That's what this is telling us up here. So I end up with n, 1 over n times mu. I end up getting this estimate. Sorry, the estimate of my, sorry, the expected value of my estimator, in this case, the mean, the sample mean, is unbiased because it actually equals the mean, what it's trying to estimate of the population.
Excellent.
Is that good? Is that all right?
Yeah.
This,
Fantastic.
the how do you call it? The handwriting got really, really terrible there at the end.
That's fine.
I'm working on it. I'm working on it. Okay. Well, most of the time your audio's coming in.
Ooh.
I could hear you every time, but then you have to, I think you have to start talking for it to actually kick on the higher level. So I'm gonna let you say something now. Tell me you have some other type of bias.
Oh dear. I hope the audio is fixed. Well, I can think of what other types of bias are there? I can think of anchoring bias.
Anchoring bias. I've heard of that. I've heard of that.
Mm-hmm. That's where we've got it's a heuristic type of bias. So it's not like a systematic, not like a specific statistical bias, but it's where you latch on to the first piece of information that you hear about something, and then you take that as like the face value. That is the fact.
Okay, so that's like that's like your target, and you're kind of going towards that target. I don't know if that's a good analogy.
Yes, it's good because it allows you to make like an informed decision about something. But it is bad because, like, a business, for example, can take advantage of it. So if you're in the supermarket buying cereal and the cereal is reduced, it was £3 and now it's 2.50. You think,
Okay.
oh, 2.50, that's really good because £3, that is your anchoring
All
bias.
right. That's the value that they gave you, and then they're letting you know that this is, so you can compare it basically.
Mhm.
Okay.
So you have to think to yourself, oh, it's on sale, but is this actually a good deal?
That's a good point. So many times. You know what? I wonder how much money I've, wasted in doing that now that you say that.
It's easy to do, isn't it?
These videos usually make me feel good.
Oh, I'm sorry.
That's okay. That's okay. At least I can start from this point out with this information. And wow, no kidding. Because that is like a kind of a driving force, isn't it? At least for me
Absolutely.
it is. For me it is. But then,
Mm.
I don't know, trying to get that bargain, I guess, whether you need it or not.
Indeed. Absolutely.
So yeah, I think there's also a couple of other bias examples of bias
Hmm.
that I was kind of while you were talking, I was paying attention while you were talking, but this happened to this happened to pop up,
Okay.
and and one thing called selection bias. Okay,
Right.
okay. So selection bias. I'm going to read from this particular. It's called Data Scientist,
Okay.
and it says. Let me make sure here. Selection bias occurs when, as the name suggests, the data selection is skewed. This generally means that you are working with a specific subset of your group rather than a random subset. So I wonder if I have an example here. Okay, so here it says, okay, so let's say you launch a new product. Okay, before spending time and money, you need to know if the audience is interested in your product. So this example is talking about sending the survey to existing customers. and not including people that may not have been previous customers. So in that sense, they're really not looking at a random sample.
Indeed.
That makes
Yes.
sense. That makes sense. So yeah, I mean, there's value in it, of course. You know what I mean? Because
Yeah.
that's a subset that you're interested in because you know that they've bought it before, but it's not at. It does have some kind of a bias just because you have to be in that group to be part of that survey if that's the way that they decided to go.
Absolutely.
Right. Okay. All right. So what do you think? Is that enough on bias?
I think so.
You think
That's
so? All
yeah,
right,
kind
all
of.
right, all right. Yeah. Well, so yeah, so now now I know when I go out to the shops, not to be too worried about, but what if it's half price, Laura? What if it's half price?
Oh, but if is it absolute rubbish though?
I know, I know, I know. All right, kiddo. Well, this is always it turned out to be fun again, and I learned something today that I'm going to carry on with me. So
Fantastic.
thank you very much.
Excellent. Thank you.
I'll see you next time. Okay.
Wonderful. Thanks. Bye. And bye to the cat.
What's the kitty cat's name?
Oh, I'm not sure.
Oh,
Um, we'll name him Corey after
Corey.
correlation bias.
Corey. That's right. Oh, that's right. That's under correlation bias. Corey. Bye, Laura. Bye, Corey. You guys. Bye.